Hi, what is IP address and what is MAC address? IP address, an Internet Protocol address, is a numerical label assigned to each device on the LAN or WAN. For example, on a computer, printer, camera, NVR, DVR, basically on any device that uses Internet Protocol. It is a logical address on a layer 3. That's how it's called also. We will explain those layers a little bit later, but we won't be going too deep into that, and because you don't really need that information for the for setting up IP cameras. Example of the IP address: version 4, 183.124.10.3. You've seen probably plenty of different IP addresses already. MAC address, a media access control address, has nothing to do with Apple, just so you know. It's a unique number assigned to every device with network interface controller, so-called NIC. It's basically every device that is connected to internet will have an interface through which it can connect. Could be that in a camera, could be in a DVR, NVR, in your computer, in your smartphone. Each of those devices will have that controller. That controller will have a media access control address, which is unique for every device. There's no two the same, but we shouldn't be. Let's assume that's not. It is a physical address in the layer 2, and it's also called a physical. It's called physical address in the layer 2, or physical address of the device. It consists of 48 bits, 6 bytes, and consists of 2 parts, each 24 bits. The first is organizational unique identifier, 24 bits, and the vendor assigned address, 24 bits. An example you have below: 1, 2, 3, that's some vendor, and that's the device itself. So basically each vendor will have certain ranges of those, like Apple, Microsoft, I don't know, Hikvision, Dahua, and so on. And then each device will have its own. And that way a switch can identify which device is which. And that's just very quick overview of the OSI model. OSI model is data processing model. So in every camera, for instance, or computer, you will have those all layers happen. So you have application, presentation layer, session layer, transport layer, and then you have network, data link, and a physical. So that's kind of for instance, let's look at the computer. You're sending an email, so you are interacting with the application on the computer, and that application then interacts with further parts, coming down to the assigning IP address of that computer, then creating the switch layer with the MAC addresses. As you remember, that NIC has a MAC address, yeah. So then computer will have MAC IP, will have a MAC address, and then comes down to the cable. So you have a socket on the back of the computer which is connected. You're sending email, you're starting from there, and the whole system is transporting all that to that Ethernet cable. It goes over the network, and maybe you're just sending this to another person, the same LAN, or maybe it goes over the internet, and then somebody is receiving that email, but it starts from that layer. So your cable is connected to the device on some other place, and is being kind of peeled off, let's call it, like an onion, and gets to the application and then somebody sees on the screen the email. And the same with the camera. You have a picture, and it's all transformed through those layers, and at the end you have a cable connected to the camera. And then this goes over the network to the DVR and VR, and it's transformed to different direction. So the transformation happens that direction or that direction. So this when you're sending, and this direction when you're receiving data. And this part is also, you can see the physical network. So you have routers, you have switches, and you have cables. So that's just for information. We won't be going into data encapsulation and stuff, how it happens, how it's being recognized, TCP, IP protocol, handshakes, and stuff like that. So we'll leave that alone. Why do we need private IP addresses? And I explain what they are in a moment. So why do we have on our planet, it's like there would be another planets and other people living there, but on our planet there's like 7 billion people. And basically almost everybody now, I'm not talking about some Africa, but almost everybody will have a device. And some people have more than one device. Then you have offices with multiple devices. So there are billions of devices. And IPv Internet Protocol, which is for Internet Protocol address with 4 numbers, has only about 4 billion addresses. So if we would go that way, we would run out of those addresses. That was also the reason why the IPv6 was invented, but it's not like fully introduced yet, only in some places, which has 340 undecillion, which I don't know that number really. 340 undecillion, which is supposed to be 340 billion addresses, 4 billion times. So it's unimaginable number of addresses. That's IPv6. But to not use this, because you would have to change certain programs and stuff to read those addresses, people invented something what's called private IP addresses. And as you remember those LANs and WANs, so each LAN is using private IP address. And private IP addresses could be, there are 3 different basically sets of them, but 2 are mostly used. It's 10 dot something dot something dot something, or 192.168 dot something dot something. This has a lot of addresses. This is only because of, you see the combination. This one has less addresses available. In most places you will see that. For bigger organizations they often use that because they want to have don't want to mix local addresses between the offices and stuff. But it doesn't really matter. So those addresses will be used only on LANs. They cannot be used over the internet. If you type in the internet one of those addresses, it will go nowhere. They're not routable. They're only valid in your local area network, LAN. And you can use them as you wish. Because they're not they're unique, but only unique on your LAN. So your neighbor can have the same address as you, because he has on a different LAN, and you can connect with him only through the internet, through the WAN. So the range is the one range is 10.0.0.0 to 10.255.255.255. There's that another range which is rarely used. You will most likely encounter this or encounter this. So 192.168.0.0 to 192.168.255.255. And as I said, they're used in LAN, they're not routable, they're working locally. So you can have another office with exactly the same IP addresses. You can pick whichever of them you want. Nobody will tell you anything. They cannot be accessed directly via internet, but only via NAT, Network Address Translation, and I will explain what it is. There's no central management. As I said, you can use whatever address you want. So in general, you cannot access those addresses, but there is a protocol in the router which helps us to do that, which is called Network Address Translation, but we will talk about it. Public IP addresses, they're used in one on the internet. They're unique across the world. There is an international organization, Internet Assigned Numbers Authority, which can assign those addresses to different organizations and businesses and so on. That's why it's called public. You can access, and your router will have both. You will have unique public address, and you will have address from your local network. How to set an IP address in a device? There are two ways. There's something what is called DHCP, Dynamic Host Configuration Protocol. It is a protocol that enables a server to automatically assign an IP address to a computer, or you can set it manually, so type in the computer and tell a computer what address it's supposed to have. So if you connect your camera, DVR, NVR, or computer to the network, and your computer and that device is set to DHCP inside, the moment it connects, the router, which manages, or some DHCP server, which is different from the router, but in most cases it is a router, will detect this device and will assign to the device IP address, and the device will accept it. So if you connect a device which is set for DHCP to the network, it will automatically acquire that IP address, and when you log into the device, you will see that it already has it. Or you can do this manually, so you have untick the box in the settings that you don't want to use DHCP, but you want to do manual. So for cameras and NVRs, DVRs, we mostly use manual, but we may initially use DHCP just to detect what addresses are available, but then we change to manual, because we don't want this address to change. But I will explain this in another lesson. What is an IP address range or subnet? So IP address version 4 consists of 4 numbers. For instance, I'm talking here about private. Excuse me. For instance, we have 192.168.10.11. So with this will be associated subnet mask, and in 99.9% of installations you will see that type of mask only. 255.255.255.0. What it means that this doesn't change, this doesn't change, and this doesn't change, only this changes. So what again it means that this is your subnet, or this is your IP range, and only this number changes depending on the device on your LAN. So how many devices maximum you could have? 0 to 255, so it's 256. But it's less than that because we don't really use 255 for some reasons. We'll be going to that now. And let's assume 256 devices. So again, in this case, this is your range, 192.168.10. So when you have cameras working together with the DVR and VR, and you're connecting laptop, they all have to have the same range to talk with each other. Thank you.